Introduction. Today, Ria is working in the kitchen with her mother. Her mother is packing a tiffin box by using a foil. Ria is watching this curiously and asks something to her mother.
Mom, what are you doing? Ria, I'm wrapping the tiffin by using foil. Mom, I want to ask you something. What is the type of foil you are using? This is an aluminium foil used for packing purpose. Okay, Mom. But how aluminium transforms into thin foil shape? Okay, I will tell you. Aluminium is the most abundant metal in the earth crust. It is extracted from the bauxite ore found in nature. Then the metal is isolated and refined from various processes. After that, the metal molds into desired shapes. Mom, I got the answer of my question and I want to know something more about this.
Students, today we will study about the general principles and processes of isolation of elements. Objectives. At the end of this lesson, you will be able to define basic terminologies, know occurrence of metals, describe concentration of ores, analyze extraction of crude metal from concentrated ore, understand thermodynamic principles of metallurgy, analyze extraction of iron, copper, and zinc, understand electrochemical principles of metallurgy, describe refining, know the application of aluminium, copper, zinc, and iron. Definition. Ores. The mineral from which the metal is conveniently and economically extracted is called ore. Gangue. The earthly and undesired constituents of minerals are called gangue. Metallurgy. The extraction and isolation of metals from ores is called metallurgy. The extraction and isolation of metals from ores involves three major steps: concentration of the ore, isolation of the metal from concentrated ore, and purification of the metal. Occurrence of metals. Oxygen is most abundant element in the Earth's crust. Silicon is the second most abundant element in the Earth's crust. Among metals, aluminium is the most abundant. It is the third most abundant element in Earth's crust. It is a major component of many igneous minerals, including mica and clay. Many gemstones are impure forms of Al2O3 and the impurities range from chromium to copper. Among metals, iron is the second most abundant. It is the fourth most abundant element in Earth's crust. It is most important both as element as well as compound. It is present in hemoglobin, which acts as oxygen carrier. Concentration of ores. The process of removing the unwanted material from the ore is called concentration of the ore. The important methods for concentration of the ore are hydraulic washing. It is based on difference in densities of ore and the gangue. In this process, ore is washed with stream of water under pressure so that light impurities are washed away, whereas heavy ores are left behind. Leaching. It is a process in which ore is treated with suitable reagent which dissolves the ore but not the impurities. Leaching of bauxite is done to obtain alumina. In this process, bauxite ore is treated with caustic soda. Al2O3 dissolves in concentrated solution, leaving behind impurities. The aluminate in solution is neutralized by passing CO2 gas and hydrated Al2O3 is precipitated. The precipitate of AlOH3 is filtered, dried and finally heated to about 1470 Kelvin to obtain pure Al2O3. Magnetic separation. Magnetic separation method is based on magnetic and non-magnetic properties of two components of ore. The ground ore is carried on a conveyor belt which passes over a magnetic roller. The non-magnetic particles leave the belt and fall off from it. The magnetic particles are attracted by the magnetic field and form a separated pile. This method is used to remove ore particles from cassiterite, magnetite, chromite, and pyrolusite. Froth flotation method. This method is generally used for the concentration of sulfide ores. The principle behind froth flotation process is that sulfide ores are preferentially wetted by pine oil, whereas gangue particles are wetted by water. In this process, a suspension of a powdered ore is made with water. Collectors like pine oil, fatty acids, and xanthates are added to it. Froth stabilizers like cresols and aniline stabilize the froth. The mineral particles become wet by oils while gangue particles by water. A rotating paddle agitates the mixture and draws air in it. As a result, froth is formed, which carries the mineral particles. The froth is light and is skimmed off. It is then dried for the recovery of the ore particles. Extraction of crude metal from concentrated ore. The concentrated ore must be converted into a form which is suitable for reduction. Oxides are easier to reduce. Thus, isolation of metals from concentrated ore involves two major steps: conversion to oxide and reduction of oxide to metal. Conversion of oxide. It is easier to reduce oxide than sulfide or carbonate ore. This can be done by two methods: calcination and roasting. Calcination. It involves heating when the volatile matter escapes, leaving behind the metal oxide. Roasting. It is a process in which ore is heated in regular supply of air at a temperature below the melting point of the metal. Sulfide ores are converted into oxide by roasting. Reduction of oxide to metal. The process of converting metal oxide into metal is called reduction. It needs a suitable reducing agent depending upon the reactivity or reducing power of the metal. For example, carbon, carbon monoxide, aluminium, and magnesium. Example on extraction of crude metals. Let's take an example on extraction of crude metals. Describe the principle of extraction of each of the following: Sn from SnO2, Zn from ZnO, Cr from Cr2O3. Let's see the solution. Sn is obtained from SnO2 by using carbon as a reducing agent. Sn is a less reactive metal. Zn is obtained from ZnO using CO as a reducing agent at 1600 Kelvin. Cr is obtained from Cr2O3 using aluminothermic process. Thermodynamic principles of metallurgy. Gibbs energy helps in understanding the theory in metallurgical transformations. The change in Gibbs energy, delta G, for any process at any specified temperature is described by the equation delta G is equal to delta H minus T delta S, where delta H is enthalpy change and delta S is the entropy change. When the value of delta G is negative, only then the reaction will proceed. If reactants and products of two reactions are put together in a system and the net delta G of the two possible reactions is negative, the overall reaction will occur. Allingham diagram. Allingham diagrams are graphs of the change in free energy formation with temperature. These are useful in explaining and predicting the extraction of metal from their ores. The height of the line in an Allingham diagram indicates the instability of the oxide. Higher the line, more positive delta G, the less spontaneous the formation of the oxide. Metals for which free energy of formation of their oxides is more negative can reduce those metals for which the free energy of formation of their respective oxides is less negative. Extraction of iron. Among metals, iron is the second most abundant. The important ores of iron are hematite or red iron ore, limonite or brown ore of iron, magnetite and siderite. Iron is generally extracted from its oxide ores. The ores generally have 20 to 55% of iron. Concentration of the ore. Impurities of clay, sand, etc. are removed by leviation. Calcination and roasting. Ore is powdered and mixed with some coal and heated strongly in a shallow furnace. By this, moisture is removed, organic matter is oxidized, sulfur and arsenic impurities are removed as volatile oxides, and the ore becomes porous so that the reactions become easier. Smelting. The calcined and roasted ore is mixed with limestone and coke in the ratio of 8:1:4 and introduced into a blast furnace. Reactions in blast furnace. Blast furnace is a tall chimney-like structure lined with refractory bricks. Dry and hot blast of air is passed from below. As the charge moves down, it passes through higher temperature zones. On the basis of variations in temperature in the different parts of the blast furnace, there are various zones where different chemical changes take place. Combustion zone. This is the lowest part of the furnace. Here, coke burns in hot blast of air. In this region, temperature varies from 1500 degree to 2000 degree Celsius. Carbon dioxide rises upwards and meets with red-hot coke. Upper zone of reduction. This is the uppermost part of the blast furnace. In this region, temperature varies from 250 degree to 700 degrees Celsius. Here, carbon monoxide reduces oxides of iron into spongy iron. Lower zone of reduction. Final reduction occurs between 1000 degree to 1200 degrees Celsius in the central region of the furnace. Carbon obtained by dissociation of carbon monoxide combines with iron and impurities also get dissolved in molten iron. Zone of fusion. Here, temperature ranges from 1200 degree to 1500 degrees Celsius. Limestone decomposes into calcium oxide, which acts as a flux and combines with the impurities of SiO2 and Al2O3 and removes them as slag. Molten iron collects at the bottom of the hearth of blast furnace. The slag, being lighter, floats over molten iron. Slag is removed through the slag hole. Extraction of copper. Copper is found both in native state as well as in combined state. The main occurrence of copper as sulfides, oxides, and carbonates. The important steps involved in the extraction of iron are concentration. The sulfide ore is mechanically pulverized into fine powder and then concentrated by Froth flotation method. Roasting. The concentrated ore is roasted on the hearth of a reverberatory furnace in excess of air. Smelting. Roasted ore is mixed with a little coke and sand and heated with excess of air in a water-jacketed blast furnace. Most of the remaining iron sulfide is converted into oxide, which reacts with silica forming fusible slag of iron silicate. The slag floats over a molten layer consisting chiefly of Cu2s and a little Fes called matte. Bessemerization. The molten matte is now introduced into Bessemer converter provided with a basic lining of lime. The blast of sand and air is blown through the mixture. FeO is removed as FeSiO3. When iron is removed completely, cuprous oxide reacts with cuprous sulfide to form copper. The metallic copper then melts and sinks to the bottom of the converter. It is poured into steel molds. As it cools down, the SO2 dissolved in it escapes, giving a blistered appearance to the solidified metal. Hence, the product is called blister copper. It contains about 98% copper. Blister copper is refined electrolytically. Extraction of zinc. The reduction of zinc oxide is carried out by coke at a temperature higher than that of Cu2O because zinc is more reactive than copper. The oxide is made into briquettes with coke and clay and then heated. Carbon monoxide formed can also reduce ZnO further to zinc. The impure zinc is called spelter. It is refined by distillation followed by rapid cooling. Electrochemical principles of metallurgy. In reduction of molten metal salt, electrolysis is done. This method is based on electrochemical principles which can be explained by the equation delta G naught is equal to minus n E naught F, where n is the number of electrons and E naught is electrode potential of the redox couple formed in the system. More reactive metals have large negative values of E naught, therefore G naught becomes positive and their reduction is difficult. If the difference in two values of E naught of redox couple is positive, then G naught will be negative and less reactive metal can be obtained from its salt by more reactive metal. Extraction of aluminium. Aluminium is extracted from bauxite Al2O3 2H2O. Concentration of bauxite is done by leaching method. Purified Al2O3 is mixed with Na3AlF6 or CaF2, which lowers its melting point of mixture and brings electrical conductivity. This process of electrolysis is known as Hall-Héroult process. Fused mixture is electrolyzed using number of graphite rods as anode and carbon lining as cathode. The graphite anode is useful for reduction of metal oxide to metal. Oxidation reduction. Non-metals are sometimes obtained from their minerals by electrochemical oxidation. For example, electrolysis of brine solution produces Cl2 at the anode. The standard reaction gives energy for oxidation of Cl- ions in water. High positive value suggests that electrolysis is required. The minimum potential difference that can achieve oxidation of Cl- ions is about 2.2 volt and N is equal to 2. But in aqueous solution there is also a reaction. This reaction can be driven by a potential difference of only 1.2 volt. Therefore, a high overall potential is required before a significant rate of reaction is achieved. Refining. A metal extracted is usually contaminated with some impurity. For obtaining metals of high purity, several techniques are used depending upon the differences in properties of the metal and the impurity. Distillation. It is the process used to purify those metals which have low boiling points. Impure metal is evaporated to obtain the pure metal as distillate. For example, zinc and mercury. Liquidation. In this method, a low melting metal can be made to flow on a sloping surface. In this way, it is separated from impurities with higher melting point, for example, tin. Electrolytic refining. In this method, impure metal is taken as anode, pure metal as cathode. Soluble salt of same metal is used as electrolyte. When electric current is passed, impure metal forms metal ions, which are discharged at the cathode forming pure metal. For example, copper, zinc and aluminium. Zone refining. It is based on the principle that impurities are more soluble in the melt than in the solid state of the metal. The impure metal is heated with the help of circular heaters at one end of the rod of impure metal. The molten zone is moved forward along with impurities and reaches the other end and is discarded. Pure metal crystallizes out of the melt. The process is repeated several times and heater is moved in the same direction. For example, it is used for purifying semiconductors. Chromatographic method. This method is based on the principle of separation or purification by chromatography, which is based on differential absorption on an absorbent. In column chromatography, Al2O3 is used as absorbent. The mixture to be separated is taken in suitable solvent and applied on the column. They are then eluted out with suitable solvent. The weakly absorbed component is eluted first, then the more strongly absorbed, and so on. This method is suitable for such elements which are available only in minute quantities and the impurities are not very much different in their chemical behavior from the element to be purified. Uses of aluminium. Aluminium powder is used in silver paints for covering iron and other surfaces, for making alloys used in automobiles and aircrafts, for making tin foils for wrapping cigarettes and confectionery. It is used for making electrical transmission cables. It is widely used for making utensils, trays, frames, and decorative articles. Because of its lightness, good conductivity, and resistance to corrosion, it is used for making useful alloys. For example, magnesium, duralumin, and aluminium bronze. Uses of copper. It is used in copper plating and electrotyping. It is used for manufacturing electrical goods, electrical cables, and wires. It is used for making vacuum pans, heating utensils, and calorimeter. Many of its compounds are used as insecticides, pesticides, and pigments. It is used in the manufacture of important alloys, for example, brass, German silver, and gunmetal, etc. Uses of zinc. It is used as cathode container in dry cells. It is used as reducing agent. It is used in galvanization of iron and steel. It is used in the extraction of silver and gold by cyanide process. It is used in manufacture of many important alloys, for example, brass, German silver, etc. Uses of iron. Iron catalysts are used in the Haber-Bosch process to produce ammonia and the Fischer-Tropsch process to convert carbon monoxide to hydrocarbons used for fuels and lubricants. Iron metal is strong but is also quite cheap. Most automobiles, machine tools, the hulls of large ships, building parts, and machine parts are made out of iron. Steel is made by combining iron with other metals. Stainless steel is used in building parts, cooking pots and pans, cutlery, and surgical equipment. It is also used in aircrafts and automobiles. Did you know? At room temperature, mercury is the only metal that is in liquid form. Bronze is a metal alloy made from copper and tin. Copper makes up the larger amount, usually between 80 to 95%. Iron is the sixth most common element found in the universe. Summary. Let us summarize what we have learned. The mineral from which a metal is conveniently and economically extracted is called ore. The process of removing the unwanted material from the ore is called concentration of the ore. Froth flotation method is generally used for the concentration of sulfide ores. Ellingham diagrams are graphs of the change in the free energy formation with temperature. In reduction of molten metal salt, electrolysis is done. This method is based on the electrochemical principles. For obtaining metals of high purity, several techniques are used depending upon the differences in properties of the metal and the impurity. These techniques are known as refining. Zone refining is based on the principle that impurities are more soluble in the melt than in the solid state of the metal. Chromatographic method is based on the principle of separation or purification by chromatography, which is based on differential absorption on an absorbent.